All right, so we're going to do a, a quick slideshow on plate tectonics. This will include a brief overview of the Earth's layers. So, just as a reminder, we have an inner core, an outer core, a mantle, and the crust. The crust, of course, is where we all live. Remember that the continental crust is the thicker crust. It's less dense than oceanic crust. Oceanic crust is the thinner crust. It's more dense than the continental crust. And it's young because of rifting, but we'll talk about that later. Some more information that you'll find in the Earth's layer slide, but seismic activity is how we generally know what the Earth is made out of. Alright, so there's going to be a little bit of unnecessary information in here. This was a free PowerPoint I found online about plate tectonics. You don't need to know the specific plates. Plates are made of rigid lithosphere material. The lithosphere is made up of the crust and the upper part of the mantle. And in contrast, that's on top of the asthenosphere, as a reminder. The asthenosphere is the plastic-like layer where that the lithosphere slides on top of. Oh, there you go. That's what I was just talking about. Plate movement. Plates of the lithosphere are moved around by the underlying hot mantle convection cells. As a reminder, you will find convection currents in the mantle. If your question says, where do you find convection currents? Your answer would be the mantle. Or, what is a unique characteristic of the mantle? You could say convection currents. Alright, so this is the big one. 3 types of plate boundaries. Divergent is dividing, convergent is colliding, transform is sliding. If you ever get lost, think of that silly Addams Family song we sang in class. Divergent is dividing, convergent is colliding, transform is sliding. These are plate tectonics. Dun-dun-dun-dun. See, I did it. You can do it too. Alright. Divergent boundaries are spreading ridges. As plates move apart, new material is erupted to fill the gap. Iceland is an example of continental rifting. Iceland has a divergent plate boundary running through its middle. Another example that we talked about in class is the Mid-Atlantic Ocean Ridge. So you will see seafloor spreading and new crusts being formed. The other example of rifting was the East African Rift Valley. So that's when crustal material is being separated, not oceanic crust. Convergent boundaries. There are 3 styles of convergent plate boundaries. Continent-continent collisions, continent-oceanic collisions, oceanic-oceanic collisions. These are very important to remember. They all have different characteristics. Continent-continent collisions forms mountain ranges, like the European Alps and Himalayas. Continent-oceanic crust collisions. This is called subduction. So you have let's see here. Show touches. Alright, so here it's sliding down. Here, let's get the paintbrush. That'd probably be better. So you have oceanic crust subducting below the continental crust. So the one that's actually doing the moving is our oceanic crust here. Alright? That's really important to remember. So, if you remember from the Watch It station, as this gets pulled down, the more and more material that is going below the surface, the faster it goes. Alright, let's turn that off. Again, this is continent and oceanic crust. The reason being is because... Alright, go back to the brush. More... Wait. Less dense. More dense. It's very important. Oceanic lithosphere subducts underneath the continental lithosphere. Oceanic lithosphere heats and dehydrates as it subsides. The melt rises, forming volcanism. The example they give here is the Andes. That's another thing to remember when you have continent-to-oceanic crust collision. You have volcanoes forming. This is also where you'll see the trench. Trenches form here in this area. Ocean-ocean plate collision. When two oceanic plates collide, one runs over the other, which causes it to sink into the mantle, forming a subduction zone, just like you would see in a continent-ocean collision. This also depends on which material is more or less dense. It's just not as big of a variation as you'll see with the continental and ocean crust. The subducting plane has been downward to form a very deep depression in the ocean floor called a trench. You will also see trenches in continent and ocean plate collision. The world's deepest parts of the ocean are found along trenches. The Mariana Trench is 11 kilometers deep. It's very deep. These are, creatures that you'll find in the Mariana Trench. Transform boundaries. This is where plates slide past each other. Nothing is created or destroyed with transform boundaries. You'll get some rubbing, and it causes earthquakes. You also will see earthquakes in subduction zone areas as well. Okay, so this was just something we didn't really talk about. I don't think you'll be tested on. But volcanoes are formed by subduction, rifting, and hot spots. You'll see volcanoes form along active plate boundaries. That could be either subduction boundaries involving oceanic, or continental oceanic. Hotspots, I don't think we talked about. A little extra information here if you want to reference it. I don't believe you'll be tested on this, though. Of course, earthquakes and plate tectonics are connected. So all the little black dots on here are areas where you see active plate boundary margins. So anytime there is a plate crashing into another plate, you're probably going to get an earthquake. Summary here, the Earth is made up of three main layers: the core, mantle, and crust. On the surface of the Earth are tectonic plates that slowly move around the globe. Plates are made of crust and upper mantle. There are two types of plates. There are three types of plate boundaries. What does that mean? There are two types of plate. Is that a mistake? Anyway, volcanoes and earthquakes are closely linked to the margins of the tectonic plates. So the three types of plate boundaries are convergent, divergent, and transform boundaries. And inside the convergent boundary, you'll see continental margins, you'll see continental-oceanic margins, and you see oceanic margins. The differences being where you're going to find mountain building, and where you're going to find trenches, and where you'll see volcanism. Vulcans, not the Star Trek creatures.